Ladies and gentlemen, I am going to present my work called Synthesis of 1,4,5-Trisubstituted 1,2,3-Triazoles linked to derivatives of gallic acid through different linkers. I will start with a brief summary. A conventional and efficient strategy was developed to obtain 1,2,3-triazoles bound to gallic acid from azide enolate cycloaddition using mild conditions. The usefulness of azide was evidenced as a viable resource to obtain a variety of substituted triazoles through activated ketones. By way of introduction, I must say that the synthesis of drug analogues is one of the most relevant approaches in medicinal chemistry, and analog design is key in the development process, modifying the structure of already active molecules, instead of ex novo synthesis. Triazole fragments are attractive prototypes, since they offer great stability even under a strong oxidative and reducing environment, and their propensity to form hydrogen bonds increases their solubility, favoring the binding towards biomolecular targets. Recently, azide enolate cycloaddition to generate 1,2,3-triazole rings, facilitated by the use of a wide series of activated ketones that are easily prepared and inexpensive. This represents a significant advantage over click chemistry, especially for producing 1,4,5-trisubstituted triazoles. Regarding the discussion of results, I must say that azides turned out to be a viable substrate for synthesis, giving way to a linear synthetic pathway option. DBU was used as a weak organic base to obtain the keton enolates and ketonitrile. However, the groups located beta to the carbonyl did not significantly influence the reaction, giving it stability. The optimal conditions for the synthesis of triazoles, time, temperature, base and solvent, were established: 48 hours, 70 degrees, dBu and anhydrous DMF, obtaining acceptable yields. Regarding the methodology, first 1 millimole of the acid halide was added, it was dissolved in DCM, 1.1 millimole of the halohydrin, 1.2 millimole of triethylamine were added, and the mixture was stirred for 10 hours at room temperature. Secondly, 1 millimole of halogenated ester was added, it was dissolved in DMF, 1.3 millimole of sodium azide was added, it was heated at 80 degrees for 3 hours. After this, 1 millimole of the corresponding keton was added, it was dissolved in DMF, 1.1 millimole of DBU was added, it was heated at 60 degrees for 1 hour. Subsequently, the corresponding azide was added and it was kept stirring under the same conditions for 48 h. Finally, all reaction crudes were purified by column chromatography and characterized by NMR and Ms. In conclusion, we can say that the work carried out shows that it is possible to obtain 1,2,3-triazoles, 1,4,5-trisubstituted compounds linked to gallic acid through the Dimroth cycloaddition azide enolate. This is how it is shown that from common raw materials it is possible to develop various molecules with possible biological activity, under mild reaction conditions and with good yields.